Now, in this lecture, we will discuss the application of Jordan lemma. So, to prove this result, so what is the statement of this question? So, this is a sine pi x over x into 1 minus x square into dx, which is equal to pi. So, this is a basically imaginary part of a function. So very clearly we see that this is an imaginary part of the function fz e raised to power iota pi z over z into 1 minus z square. So here I consider, if it is a cos or sine, I consider this kind of function. So this is z into 1 minus z square. So I consider to prove this result of this kind of function, right? Now from this first step, so poles of function fz are given by z into 1 minus z square, which is equal to 0. So it implies z equal to 0, 1 and minus 1. So all of these are simple pole. So first remember, all of these are simple pole and they lie on a real line. It means I would like to remove these singularity by taking a semicircle. Now this, if I take a real line, so this is a real line. In this real line, this point is origin, this is origin, and this is a semicircle of radius capital R. So here it is minus R and here it is capital R. So this is a semicircle of capital R. Now singularities are on the real line. If this point is minus 1, this point is minus 1 and this point is 1. So this is one singularity. So this is a second singularity and this is a third singularity. So 0, 1 and minus 1, all of these are singular point of this our domain. Now to remove these singularity, I will take a circle, half circle of radius r1, of radius r2, r, of radius r3, of radius r3. So I am taking this region. Now this region, so removing these small circles. So this circle is, if this I am taking this circle is a capital gamma tau and this is a gamma 1, this is a gamma 2 and this is a gamma 3, this values. Now its radius is r1 and its radius is r2. So its value is minus r2 and r2 because it is around origin. Here check that this point is 1. So this point will be, I write here, this point will be 1 minus 1 plus r1 and this is negatives. So this point will be minus 1 and minus r1, these values, and here minus r2 and this point will be, and this point will be, so this is 0, this is a r2 and this point is 1 and this is a 1 minus r3. So here it is 1 minus R3, and here it is 1 plus R3. So all of these points of this kind. Now, if a point move from this point to this point, so this is integration around tau first, then on the real axis, this real axis from this to this point, then around the gamma 1, then again on the real axis, then around gamma 2 from this to this, then again on the real line, then on the gamma 2, then again on the real line this values. Now the function is analytic in this domain. If function is analytic in this domain, then by using residue theorem, so by using the residue theorem, by Cauchy residue theorems, Cauchy residue theorem, because it is not a Cauchy theorem, Cauchy-Gauss theorem B, I can say that because it has no singularity. Now by using Cauchy residue theorem, I start from this point. So this is a first integration 1. This is from minus R to minus 1 minus R1. So this is a real line. So what we get, fx into dx, because it is a real line, number 2. So I move from this to this. Now from this plus, which is integration gamma 1 f of z into dz, this, and next this is plus from this point, so this point is minus 1 plus r1, and this is from minus r2, so this is fx into dx, because it is a real line. Now this, so this is again plus integration, so this is again plus integration gamma 2 f of z into dz. So this is about gamma 2 fz into dz. Now next, again real line. So again real line, so this is a integration. So from this point, so what is this point? Gamma 2. This is R2 R2 to 1 minus R3, R2 to 1 minus R3. So this is equal to f of x real line into dx plus this values. Now this is from 1 R2 to 1 minus R3. So after the integration gamma 3, so what is gamma 3? F of z into dz, third circle, and then again about a real line. So what is real line? So real line is from 1 plus R3 to capital R. 1 plus R3 to capital R. So this is a real line. So f of x into dx plus integration of this circle. So this is a tau f of z into dz, and total term is equal to 0, because this function is analytic. So total term is equal to 0. So this is written as equation number 1. So see, so check it very carefully. So it is very lengthy question. So it involves 1, 2, 3, 4, 5, 6, 7, 8. 8 integration. So see it very carefully. So very carefully. Now my aim is to find the integration around gamma 1, gamma 2 when R1, R2 0 and gamma 3. And then this is third integration and fourth around tau when R approaches to infinity. So that is my aim is to find the values of this. Now first I take this integration gamma 1. Now here it is gamma 1. So here the singular point is minus 1. So remember that. That point is minus 1. So here K1 can be found in this way. So what is K1? The K1. So this will be K1. I write it as K the K1. So what is the limit of Z approaches to minus 1 into Z plus 1 into f of Z. So this is suppose this value is K1. If I write it is K1. So I find this values. So this value will become, so just to simplify, so this value will become e raised to power iota pi z, and here it is z into z1 minus z the 1 plus z. So remaining part is 1 minus z, and limit is z approaches to minus 1. So this value will become, so just see that minus 1 minus 1 2. So this value is become e raised to power minus iota pi over. So this value is minus 1 and this is 2, this values. So this value is cos pi which is equal to minus 1 minus iota sin pi, that is 0. So minus minus 1. So this value is equal to 1 by 2. So I find the value of this integration K1. So this is equal to, if I substitute this value, so what is cos pi e raised to power minus iota pi over this. So its value is equal to 1 by 2, right? So what is the value of this integration? So what is the value of integration at the rate of gamma 1? So limit of first integration R1 approaches to 0, integration of, so this is integration of f of z into dz, which is around gamma 1, which is equal to iota, then iota theta 2 minus theta 1. So here it is which kind of direction? So this kind of direction. So this is 0 first, then first is 0 minus pi, and this value is 1 by 2. So this integration is minus pi iota by 2. So this is the value of first integration. So this is a minus pi iota by 2. So remember this values are. Now second, to find the integration of second, so that is around the uh, values, that is around the value of 0, z equal to 0. So what is limit of here z approaches to 0? So this is z into fz. So z is cancelled. So limit of z approaches 0, and this value is e raised to power iota pi z over 1 plus 1 minus z square. 1 minus z square. So substitute the value of z. So this will become a 1, right? So if this will become a 1, so again on the same parallel line of action, so we get limit r2 approaches 0, integration of gamma to f of z into dz, which is equal to iota, again 0 minus pi, because clockwise direction. What is k? So this is 1, so this value is equal to minus pi iota. So this value is again minus pi iota. So here it is pi iota and this value is minus pi iota. Now next term, which is third part, limit z approaches to 1, and in that case z minus 1 into fz. So this value, in this case, z limit of z approaches to 1, so remaining part e iota pi z over z minus 1. So z minus 1, the 1 minus z, so this value, if it is a z minus 1 into fz, so this is a z first term, and then minus z plus 1, right? Now substitute its value. So this value will become e raised to power iota pi number 1. So its value is minus 1. Here minus 1 into 1 into 2. So what its value? So this is a pi iota by 2. So this is a pi iota by 2. E raised to power iota pi when z approaches to this value. So this is a pi iota by 2, and this value then integration of third part limit. So I write here, so limit r3 approaches to 0 around gamma 3 fz into dz. So this is iota, same line of action, 0 minus pi, this values, and this value, sorry, here this value is cos pi, so this is a 1 by 2. So this is a 1 by 2. If it is 1 by 2, so this term will become a 1 by 2. So this is a minus pi iota by 2. So all the three terms are negative. So we get the value of all the three terms. This is pi minus pi by 2, minus pi iota by 2, minus pi iota by 2, and this is minus iota pi. Now next is the fourth part, which is a z equal to 0. So this value can be uh, find out with the help of, so first I write these values as equation number 3. Now third part, so we will apply to find the integration by Jordan lemma. So what is the that integration? So that integration is tau, or here f of z into dz. So what is this value? So this value is basically e raised to power iota pi z into 1 by z into 1 minus z square into dz, this values. So here, to apply Jordan lemma, I take this function. If I take this function and z approaches to infinity, so this function approaches uniformly approaches to 0. So it implies this function limit of f of z. So this function 1 by z into 1 minus z square, this approaches to 0 as z approaches to infinity, right? So it means this लिमिट यानी कि इंटेग्रेशन r approaches infinity approaches to 0, so it implies limit r approaches to infinity and this value is around tau, and this is this into this, which is a fz into dz. This is equal to 0, so this is by Jordan lemma. So this is by Jordan lemma. So this limit is equal to 0. Now in equation number 1, so this value we find the integration of this value. Now as we take the R1, R2 and R3, as we take equation number R1 0, R2 0, R3 0 and capital R approaches to infinity, and substitute all the values in these equations, which is a 1 2 3, I think in 3 and 4, in 3 value of 3 we get, right. Now I will substitute in equation number 1. So this value, now I am going to equation number 1. So check that. So this is a value, this a, the total sum is equal to minus 2 pi iota. So this is, if I write the sum of 3 and 4, so this is a minus 2 pi iota. Now from this, so what is its value? Its value is minus pi iota by 2, this value. What is its value? It is minus pi iota. And what is gamma 3? So its value is again minus pi iota by 2. And what is its value? Its value is equal to 0. Right? So this total sum minus pi iota, this and this. So this is a 2 pi iota and this is 0. So this right hand side can be written as 2 pi iota, right. Now I will solve this integration. So just see that. So I will substitute the value of now from this. So this is minus infinity and this is 0. So this is 0 means, so this is minus infinity to minus 1. So this value is this. Now this value is equal to minus 0. So this value is minus 1 and this value is 0. So this value is 0. Now this value is again, this value is 0 and this value is 1. So this value is 1. So this value is 0 and this value is 1. So this term is minus pi iota and this value is 1 to r, 1 to infinity. So this term can be written as this term can be written as 1 to infinity, this value. So what we get the integration minus infinity to minus 1 f of x into dx. So I will shift these three values on right hand side. Now this is plus minus 1 to 0 f x into dx, this value. Again this is plus 0 to 1 fx into dx, this value, and this is 1 to infinity, this value 1 to infinity fx into dx, and this total, this and this, which is a 2 pi iota. So I take it on the right hand side, this values. Now this integration is minus 1 infinity to minus 1. So this two term combined minus infinity to 0, and this is from 0 to infinity. So what we get? So we get this integration minus infinity to infinity. So now this term minus infinity to minus 1, minus 1 to 0, 0 to 1, 1 to infinity. So this total integration is equal to, minus infinity to, this is minus infinity to 0 f of x into dx plus this is 0 to infinity fx into dx, and this is equal to 2 pi iota. Now t f of x into dx, which is equal to 2 pi iota. So directly, so it implies z minus infinity to infinity fx dx is equal to 2 pi iota. So it implies 2 times 0 to infinity f of x into dx, which is equal to 2 pi iota. So this 2 is cancelled with this term. So this values. Now substitute the value. So what we get? We get integration 0 to infinity, this values, and e raised to power iota pi x over x into 1 plus x square into dx, which is equal to pi iota. Now simplify this result. So this is a cos pi x. It implies this is a 0 to infinity cos pi x plus iota sin pi x over x into 1 plus x square into dx, which is equal to pi iota. Now equating real and imaginary part. So if equating in this case, so equating real and imaginary parts. So what we get? We get integration 0 to infinity cos pi x over x into 1 plus x square into dx equal to 0 and integration 0 to infinity sine pi x over x into 1 plus x square into dx, which is equal to pi, so which prove our result. So in this way we can find the value of this integration. So this is our result.